This is June 2015 AS2 and we'll be looking at question 5. Question number 5 is a question about EZ isomers. And the easiest way to do this question is just try to draw out all the different stereoisomers that you can, geometric isomers that you can. And you can see in this molecule that we have 2 double bonds, one here and one here. So each of those double bonds will be either an E or a Z. And so we'll have a combination of the 2 isomers. So let's try drawing out one first of all. So we've got our first double bond here. And we've got a hydrogen and a bromine attached to the terminal carbon. And then the second carbon has a hydrogen attached to it and then is attached to a carbon, which is also attached to a hydrogen, but then has a double bond attached to a carbon and a hydrogen and a bromine. So the first one you draw will be completely random. And then you need to work out whether this each of the double bonds are E or Z. Okay, so let's take the double bond on the left hand side first. And for EZ, for assigning EZ, we have to assign priorities to the groups attached to each of the carbon. So let's take carbon number 1 here. So the one with highest priority is obviously going to be bromine. So that's priority 1, and this is priority 2. Okay, then jumping to carbon number 2, assigning priority again, we're going to have number 1 on the bottom here, because carbon has a higher priority than hydrogen, and so priority number 2 is the hydrogen. So determining whether it's E or Z, if the highest priority group is on the same side, it is Z, and if they are on opposite sides, then it is E. So again, think Z, same side. So here we have got the highest priorities are on the same side, and so this double bond is Z. Okay, then on the other side we need to do the same thing. So we'll take a different colour, and for carbon number, let's call it 3 here, we can assign the priorities of 1 and 2. And again for carbon number 4, bromine has a higher priority, so it's priority 1, hydrogen is priority 2. And here, looking at the numbers circled in green, you can see that the highest priority groups are on opposite sides. So we've got 1 here and 1 here, so they're on opposite sides, so that is an E. So this isomer that I have drawn is ZE. Okay, let me draw it with just one of the groups switched. So it's easiest if you just swap one group at a time. So let's take these groups here and swap them around. So what we would have then is this. So we can see it's exactly the same molecule. It will have the same relative molecular mass because we've got the same groups in it, they're just arranged slightly differently. So again, assigning our priorities, we've got 1, 2, and for carbon number 2 we've got 1, 2. So here we can see that our groups are, our highest priority groups are on opposite sides of the double bond, and so this is an E. And this double bond hasn't changed. So we've got 1, 2, and 1, 2. So again, this is an E double bond. And so here we've got E, E. Okay, so we've got 2 so far. We've got the ZE and we've got the EE. And let's try changing one again. So we finished off there with the EE. So let's switch the order of these groups here and see what we get. So again, we're just changing one thing. Okay, so let's assign our priorities again. For carbon number 1, bromine has a higher priority than hydrogen, and carbon has a higher priority than hydrogen also. And so we can see that our highest priority groups are on opposite sides of the double bond, and so this is an E. And then for the second double bond, for carbon 3, carbon has a higher priority than hydrogen, and bromine has a higher priority than hydrogen. And so what we find here is that we've got our highest priority groups on the same side, and so this is a Z isomer. So here we've got an EZ combination. Now, before you're tempted to think that this is a separate isomer, have a look at the isomer that's above it, the ZE isomer. And what we can see from that is that this is exactly the same. It's just flipped around. So if you can imagine this completely flipped over 180 degrees, then it's the same isomer. Or in other words, you could, if we drew the mirror image this way, so if we reflected it in that mirror, it would be the exact same molecule. And so, because this is the same molecule, this doesn't count as a separate isomer. So the ZE is the same as the EZ. And the reason that is because our two end carbons, so this carbon and this carbon, they have the same groups attached to it, and that's why it works that we can count them as one. Had it been different groups, it might not. It wouldn't have counted as counting them as the same. They would be two separate. So say, for example, this group was instead chlorine. We couldn't take them, the ZE and the EZ, to be the same isomer. They'd be two separate isomers. But because there is symmetry in this molecule, they are the same. Okay, so let's see if there are any other combinations. So this time we are going to keep carbon 4 as the same and go back and change carbon 1 into the original arrangement. So changing carbon 1 back to the original arrangement of hydrogen on the top and bromine on the bottom, and then carbon 4, as we've just recently rearranged it, to bromine on the top and hydrogen on the bottom. Okay, so assigning our priorities, for carbon number 1, bromine has a higher priority than hydrogen. Carbon has a higher priority than hydrogen for carbon 2. We can see that our highest priorities are on the same side, and so this is Z. And for our second double bond for carbon 3, carbon has a higher priority than hydrogen, and bromine has a higher priority than hydrogen. And so we can see that again the highest priorities are on the same side of the double bond, and so this is ZZ. And so we have our last combination, ZZ. So we have ZE, EE, EZ, but these two are the same, and so these only count as one, so you can almost score this out because it's the same as ZE. And then we have ZZ, so the total number of EZ isomers are 3.